This is the Edexcel June 2019 higher tier paper 2, which is a calculator paper. Question 1. So we've got an inequality. We're solving in the inequality. 14n is greater than 11n plus 6. So we want to get rid of the smallest n first. So that's 11n. And we're going to take 11n away from both sides. 14n take away 11n is 3n. So 3n is greater than 11n's gone, so 6. 3n is greater than 6. To get n by itself, we want to divide both sides by 3. So n's by itself, n is greater than 6 over 3, 2. So n is greater than 2. Part B. On the number line below, show the set of values of x for which x plus 3 is bigger than negative 2 and less than or equal to 4. So we want to get x by itself. At the moment we've got x plus 3. So we want to take 3 away from everything to get x by itself. So negative 2 take away 3 is negative 5. X plus 3 take away 3 is x. And 4 take away 3 is 1. So this is the inequality we need to draw. So we're going to have a circle at negative 5, a circle at 1, a line between them. And if it can equal the number, we need to colour in the circle. So it can equal the 1, so we'll colour in the circle at 1. Question 2. On the grid below, draw the graph of y equals 2x minus 3 for values of x from negative 2 to 4. And negative 2 to 4 are the same x values we've got on the graph. So to do this, we can have a table of values. So we've got the x and the y, and our x values go from negative 2 to 4. So negative 2, negative 1, 0, 1, 2, 3, 4. We can use a calculator to work out the y values. So let's grab the calculator. Y equals 2x minus 3. So 2, and then I'm going to put some brackets in for the x values, minus 3. So when x is negative 2, inside the brackets, I'm going to write negative 2. And that's negative 7. So when x is negative 2, y is negative 7. Then we can do negative 1. So we'll change the inside the brackets from negative 2 to negative 1, and we get a negative 5. And 0 next. Negative 3. You can start to see a pattern emerging. I'll do one more on the calculator, and then I'll just fill them in. So we've got negative 1. So we can see it's going up in 2s, going up by 2 every time. And that's called the gradient of the graph. So it's going up in 2s every time. So we can complete the rest of the values because we can see the pattern. So let's write these, or let's draw these on the graph. So when x is negative 2, y is negative 7. So the coordinates negative 2, negative 7. X is negative 2, y is negative 7. We've got negative 1, negative 5. 0, negative 3. 1, negative 1. 2, 1. We've got 3, 3. And 4, 5. So there are points. We can join them up with a straight line, use a ruler, straight line, and there's our graph. Question 3. Hannah is planning a day trip for 195 students. She asks a sample of 30 students where they want to go. Each student chooses one place. The table shows information about her results. So we've got different places and different numbers of students that want to go to each place. So it's a sample of 30 students. Work out how many of the 195 students you think will want to go to the theme park. So 10 out of 30 in the sample want to go to the theme park. And we can say that's 1/3. So if the sample is representative of the 195 students, we can say that 1/3 of the 195 students want to go to the theme park. So we'll get 1/3 of 195. So either 1/3 times 195 or 195 divided by 3. 195 divided by 3 is 65. So we'll say that 65 students will want to go to the theme park. And then there's a second part, state any assumption you made and explain how this might affect your answer. So the assumption we've made is that the sample is representative of all the students. So if there were students from different year groups going, and Hannah had only asked year 7 students where they want to go, the year 7 students might not want to go to the same place as the year 11 students. So the sample wouldn't be representative. Or if she'd only asked boys and there are boys and girls going on the trip, the sample wouldn't be representative of that 195 students. So we've assumed the sample is representative of the 195 students. And how would this affect their answer? Well, if it wasn't, the answer would be wrong or not accurate. So if it wasn't, isn't or wasn't, the answer would not be accurate or would be wrong. Question 4. A container is in the shape of a cuboid. So we've got the measurements given to us in the diagram, 30 centimeters by 6 centimeters by 19 centimeters. The container is 2/3 full of water. A cup holds 275 milliliters of water. What is the greatest number of cups that can be completely filled with water from the container? So we need to know the volume of the container. So volume is length times width times depth. So the 3 measurements multiplied together. So 30 times 6 times 19. 30 times 6 times 19 is 3,420. And that's in centimeters cubed. The container is 2/3 full. So we only want 2/3 of this. So this is the container, the amount of water. So volume of water is 2/3 times 3,420. we can use a time sign to say of. So this is 2/3 of 3,420. So 2/3 times answer is 2,280. And again, centimeters cubed. Now, the cup measurements, we've got milliliters. And the amount of water we've got centimeters cubed. And they are actually the same thing. So 1,000 centimeters cubed equals 1 litre. And 1,000 milliliters equal a litre. So centimeters cubed and milliliters are the same thing. So how many cups of water can we get? We've got 2,280 milliliters of water. A cup holds 275 milliliters. So if we divide, so answer divided by 275, we get 8.29. What's the greatest number of cups that can be filled? Well, 8 cups. 8 cups can be filled to the top. Question 5. ABC is a right-angled triangle. So we've got the diagram here. We can see we're given one angle and one length, and we need to calculate the length of AB. So it's a SOHCAHTOA question. We've got an angle and a length, and we're finding another length. So we know it's SOHCAHTOA. It's a right-angled triangle, so it could have been Pythagoras, but that's when we've got only the lengths. When we've got 2 lengths and we work out another. So it's SOHCAHTOA. Let's label the triangle. The hypotenuse is the longest side, opposite the right angle. The opposite is opposite the angle we're using. And the adjacent is in between the angle we're using and the right angle. So we're using SO, KA, or TOA. We have H as 16, so H is in the question. O is X, so that's in the question. A isn't, so cross out the ones with A, it's SO. Sine, so that means sine theta equals opposite over hypotenuse. Theta is the angle, which is 38. So sine 38 equals opposite, which is X, over hypotenuse 16. We want to find X, and to get X by itself, we need to multiply both sides by 16. So let's do that. So 16 times sine 38 equals X. So let's type that in the calculator. 16 sine 38, and we get 9.85. We want 2 decimal places, 9.85. Question 6. Sally used her calculator to work out the value of another number y. The answer on a calculator display began 8.3. Complete the error interval for y. So this is truncating. So it began 8.3. She's essentially just crossed off anything that came after. And that means the lowest thing it can be is 8.3. And it can be anything all the way up to 8.4. So it can be 8.3999. It can be anything up to 8.4, but it doesn't include 8.4, which is why there's no line under this inequality. So her number was anything between 8.3 and 8.4. It can include 8.3, and it can't include 8.4. Question 7. £360 is shared between Abby, Ben, Chloe and Dinesh. The ratio of the amount Abby gets to the amount Ben gets is 2 to 7. So Abby to Ben, 2 to 7. Chloe and Dinesh both get 1.5 times the amount Abby gets. So Abby got 2 parts. 1.5 times 2 is 3. So they both get 3 parts. Work out the amount of money that Ben gets. So how many parts do we have in total here? 2 plus 7 is 9, plus 3 is 12, plus 3 is 15. So we've got 15 parts, and we've got £360. So each part's equal. So 360 divided by the 15 parts tells us each part is £24. So Abby gets 2 lots of £24, Ben gets 7 lots of £24, Chloe and Dinesh get 3 lots of £24 each. So how much does Ben get? He gets 7 lots of £24, which is £168. Question 8. Write 0.00562 in standard form. So we've got a calculator, and the calculator is actually going to do this for us. So 0.00562, press equals, and we get a fraction, but then the S to D button turns it into standard form. 5.62 times 10 to the power of negative 3. If we didn't have a calculator, we know standard form is a number between 1 and 10. So it's got to be 5.62 times 10 to a power. And then we work out how many times we have to times or divide by 10 to get this number. So 5.62 divided by 10, 1, 2, 3 times. So it's a power of negative 3. Because we divided by 10, it's negative. If we times by 10, it's positive. Part B, write 1.452 times 10 to the power of 3 as an ordinary number. Now again, the calculator will do this for us. But times 10 3 times. So 1.452 times 10, 1, 2, 3 times. It's 1,452. Now on a calculator, if we type 1.452, and then we can use this standard form button down here, times 10, and then we just write the power. And there's our answer. Question 9. The circumference of circle B is 90% of the circumference of circle A. Find the ratio of the area of circle A to the area of circle B. So this is a scale factor question. We need to know that the scale factor for length, the scale factor for length is the scale factor for length. The scale factor for area, so is scale factor squared, and the scale factor for volume is scale factor cubed. So here we're given the length, the circumference is a length, and circumference of B is 90% of the circumference of A. Find the ratio of the area of A to the area of B. So we've got A and B. We want it as a ratio. The circumference of B is 90% of the circumference of A. So if A is 100%, B is 90%. 90% of A. And let's simplify this. So that's 10 to 9. Divide both by 10. So this is for length. We want area. So we need to square the scale factor. 10 squared is 100. 9 squared is 81. So the ratio of the area of A to the area of B is 100 to 81. Part B, square E has sides of length E centimeters. Square F has sides of length F centimeters. The area of square E is 44% greater than the area of square F. So we've got E to F. So again, if F is 100%, E is 44% more. So 44% of 100 is 44. So add it on, 144. This is for area. We want length this time. So to go from area back to length, we're going to square root. And these are both square numbers, so that's helpful. Square root 144 is 12. Square root 100 is 10. So that's 12 to 10. It doesn't say we have to, but we can simplify this by halving them both. 6 to 5. And there's our answer. Question 10. Mary travels to work by train every day. The probability that a train will be late on any day is 0.15. So we need to complete the tree diagram. So if the probability of it being late is 0.15, the probability of it not being late must be 0.85, because the probabilities have to add up to one whole. And it's the same probability on Friday as it is on Thursday. So we just need to complete the same probabilities in each box. Part B, work out the probability her train will be late on at least one of these days. So we either want late, I'll just put a star here, late, not late, because that's late on Thursday, not late, because that's late on Friday. So we want everything apart from not late. So we can either work out these three probabilities and add them together, or work out this one, not late, and do 1 minus the answer. Because all these probabilities again have to add up to one whole. So either one of those two approaches would work. Let's do 0.85 times 0.85. And I've got 289 over 400. 289 over 400. So that's the probability of it being not late on both days. So to find it being late on at least one day, we can do 1 minus that answer. 1 minus answer, which is 111 over 400. Question 11. The grouped frequency table gives information about the times in minutes that 80 office workers take to get to work. So how long people take to get to work, shown on the table. Complete the cumulative frequency table. So in a cumulative frequency table, we add up as we go. And we can see this from the times we've got. So 0 to 20 is the same as the 0 to 20 in the first table. And then we've got a 0 to 40. So 0 to 40 is the first two added together. So everyone in 0 to 20 and everyone in 20 to 40. So that's 35. And then 0 to 60, again we add on the next one. So adding on another 20 makes 55. 0 to 80, add on another 15, which will be 70. Up to 100, so add on 8, 78. Then add on 2 more, gets to 80. And we were told there were 80, so we've got the right number. So part B says draw the cumulative frequency graph. So in a cumulative frequency graph, we plot the top point. So we're going to be plotting 20, 5, 40, 35. So after 20 minutes, 5 people have arrived. So 25, 40, 35. $60, 55, 80, 70. 60, 55, 80, 70. And finally 2 more. 178, 120, 80. 100 against 78. 120, 80. And then we're going to join them up. I'm going to try and do a smooth curve here. So join them up with a curved line that connects all the points. And there is our cumulative frequency diagram. Part C says, use your graph to find an estimate for the percentage of these workers who take more than 90 minutes to get to work. So 90 minutes is here. So we go up to the line and across. It looks like it's there. So I've got 74. You can get a slightly different answer because everyone's line will be slightly different, but it should be around the same area. So I'm going to read off 74 here. So how many take more than 90 minutes? So 80 take away 74. So after 90 minutes, 74 are at work. So 80 take away 74 is 6. So 6 people out of 80 in total, but that's not a percentage. So it's 6/80ths. And then to make it a percentage, times 100. So 6/80s times 100, and I've got 7.5%. So if you read off a slightly different number, you'll get a slightly different answer. But there'll be a range of acceptable answers. Question 12. OAB is a sector of a circle with center O and radius 7 centimeters. The area of the sector is 40 centimeters squared. Calculate the perimeter of the sector. Give your answer correct to 3 significant figures. So this is a two-part question. We've got a sector, the area of a sector is theta, which is the angle in here, over 360 times pi r squared. So we're going to use this area of a sector formula to find the angle, and then once we've got the angle, we can calculate this arc length here, which is what we need to find the perimeter. So let's use this area of a sector formula. So we're finding this theta, this angle, times pi times the radius, which is 7 squared, equals 40. We can think of this as all one term. So it's kind of like pi times 7 squared times theta over 360 equals 40. It's all multiplied together. So to get theta by itself, we need to multiply both sides by 360. So 40 times 360 equals 14,400. And then to get theta by itself, we divide both sides by pi times 7 squared. So 7 squared is 49. So it's 14,400 over 49 pi. And it doesn't leave it in terms of pi, it gives us a decimal. So we've got 93.54. We want the whole number really, because we're going to use it in another calculation. So I'm going to store it in my calculator. I'm going to press Shift Store A. Your calculator might be slightly different. If you've got an STO button, you just press Store and then the letter. So I've stored that as A, and I'm going to use this in my calculation for the arc length. So arc length is theta over 360 times 2 pi r. And we now know theta is 93.54 and the radius is 7. So we can put this straight in the calculator. We didn't really need to store it. We can still use the A and S button. So answer over 360 times 2 times pi times 7. So that will give us our arc length, which we've got 80/7 or 11.4 to 3 significant figures. So we've got 11.4 centimeters to 3 significant figures. That's the arc length, that green arc there. We want the perimeter, so that's the arc length plus 7 plus 7. So the perimeter is 11.4 plus 7 plus 7, which is 25.4. So we've got 25.4 centimeters. Question 13. Show that 6 plus, then a big bracket, x plus 5 in a small bracket, divided by a fraction, x squared plus 3x minus 10 over x minus 1 can be simplified to ax minus b over cx minus d, where a, b, c and d are integers. This looks complicated, but it's just a simplifying algebra question, an algebraic fraction question. And if we take it step by step, we will be able to simplify it to the form we're given. So where can we start? We can start by changing this divide. So dividing by a fraction is the same as multiplying by the fraction and flipping the fraction over. So I'll change it to a times, and I'll write x minus 1 on top. So the denominator becomes the numerator, and the numerator becomes the denominator. And now I'm going to multiply these. So I'm going to multiply x plus 5 by x minus 1 over x squared plus 3x minus 10. And x plus 5 is the same as x plus 5 divided by 1, or x plus 5 over 1. So that looks more familiar now. We're multiplying fractions, and when we multiply fractions, we multiply the top and multiply the bottom. So now we've got 6 plus, and then we've got one big fraction. We've got x plus 5 times x minus 1 on top, and 1 times x squared plus 3x minus 10 is x squared plus 3x minus 10. Now our denominator, our x squared plus 3x minus 10, can be factorized. It's a quadratic. So let's factorize that. So we're looking for what multiplies to make negative 10 and what adds to make a 3. So it's going to be a 2 and a 5. Let's put an x in both brackets. And we need a positive 3. So we're going to have a plus 5 take away 2. A positive 5 and a negative 2. They multiply to make negative 10 and add to make a positive 3. Now we can simplify our fraction. We can divide top and bottom by x plus 5. So what's left? 6 plus x minus 1 over x minus 2. And now we need to add these together. Again, like we did previously, this is adding fractions. At the moment, 6 is 6 over 1. And we need to add fractions. In order to add fractions, we make the denominators the same. So we can multiply the top and the bottom of 6 over 1 by x minus 2. So let's multiply the top by x minus 2. 1 times x minus 2 is x minus 2. So now we've got two fractions with the same denominator, so we can add them together. And we could expand the bracket first, or we could do it after. It doesn't make a difference. So we're going to write it all over x minus 2. I'm going to expand it after. So 6 times x minus 2 plus x minus 1. I'm going to put that in a bracket. If it was negative, if it was a taking away, if we were taking away the fractions, it would be important to keep this in a bracket. Where it's a plus, it doesn't actually matter, but I'm just going to do it. Now we need to expand these brackets. So we've got 6 times x, which is 6x. 6 times negative 2, which is negative 12. And we've got a 1 times x, which is x. And a 1 times negative 1, which is negative 1. So what's left? We've got 6x and x. So 7x. Negative 12, take away 1. Negative 13 on top. And x minus 2 on the bottom. So we've simplified into the form we wanted. So ax minus b over cx minus d. So a is 7, b 13, c is 1, and d is 2. Question 14. A car moves from rest the graph gives information about the speed, v meters per second, of the car t seconds after it starts to move. So we've got the speed changing as it moves. Calculate an estimate for the gradient of the graph at t equals 15. So here's t equals 15. We want an estimate for the gradient. So in order to do that, we draw a tangent. So a straight line that touches this point, just touches it and doesn't go through it. So let's try and get this right. So I'm going to draw the line. I just need to move it so it's a tangent. Somewhere around there. Maybe a little bit. I'll keep moving it until I like where it is. Okay, something like that. Somewhere around there. So we're going to use this line now. I will also expand it. So you draw a line with your ruler until you find a tangent. You find the point that you think represents the gradient at that point. And now we need to work out the gradient of this tangent. So let's try and find a good point. And where are the good points? So it looks like we've got 17.5, 20 here. And let's look for something over here. 5, 10.5. So we'll go with 5, 10.5 here. So we're just finding 2 points on our line, and we're going to use them to work out the gradient. So the gradient is the change in y. So the change in y over the change in x. So the change in y, so our y's are 20 and 10.5. So 20 minus 10.5 over the change in x, 17.5 and 5. So let's type that into the calculator. 20 minus 10.5 over 17.5 minus 5. So I've got 19 over 25, or 0.76. So I'll go with 0.76. And describe what your answer represents. So the gradient is the acceleration. So on a speed time graph, the gradient of the graph is the acceleration. So it is the acceleration. I think it was a car of the car. Okay, and another question on this, part B, work out an estimate for the distance the car travels. That's the area under the graph for the first 20 seconds of its journey. Use 4 strips of equal width. So the first 20 seconds of the journey in 4 strips. So we're going to have go up at 5 seconds, go up at 10 seconds, 15 seconds, and 20 seconds. And we're going to have a triangle for the first one. and then trapeziums for the others. So we're going to work out the area of these four shapes as our estimate for the area under the graph. So the area of a triangle is half base times height. So it's half 5 times 4. So half of 5 times 4 for the triangle. I'll do the calculations after. The trapezium is half the sum of the parallel sides. So half of 4 plus 12 times the distance between them, which is 5. So it's going to be 5 for all of them. And then the next trapezium is going to be half of 12 plus 17, 18 even. Half of 12 plus 18 times 5. And then the last one, half of 18 plus 20 times 5. So we can use a calculator for these if we need to. So half of 20 is 10. Half of 16 is 8. 8 fives are 40. Half of 30 is 15. 15 fives are 75. And half of 18 plus 20 is going to be the middle of them, which is 19. And 19 times 5 is 95. So we're going to add these up. 95 and 75 are 170. Plus on 50 is 220. This is a calculator paper, so you can use the calculator to do all of those sums. Question 15. Make m the subject of the formula. So f equals, we've got 3m plus 4 over m minus 1. So we need to get m by itself. The first step, we're going to get rid of the fraction, multiply both sides by m minus 1. So f times m minus 1 equals 3m plus 4. Then let's expand this bracket. F times m is fm. F times negative 1 is negative f. So we've got two m terms now. So we need to get them on one side and everything else on the other side. It doesn't matter which way round we do this. I'm going to get the m's on the left side. So I'm going to take 3m from both sides. So I've got fm minus f minus 3m equals 4. And then I'm going to plus f to both sides. So fm minus 3m equals 4 plus f, or f plus 4. Now I've got my m's on the same side. To get m by itself, I need to factorize m. So factorize m out of the left side. So m's outside the bracket. M times f makes fm. It's a negative. M times 3 makes 3m. So at the moment I've got m multiplied by f minus 3. To get m by itself, I need to divide by f minus 3. So m equals 4 plus f, or f plus 4, over f minus 3. And so m is the subject of the formula. You could also have, if you did it the other way around, -4 and negative f on top, and 3 minus f on the bottom. Question 16. The straight line L has the equation 3y equals 4x plus 7. The point A has coordinates 3, -5. Find an equation of the straight line that's perpendicular to L and passes through A. So to know the equation of a line perpendicular to L, we first need to know the gradient of L. So for L, the equation is 3y equals 4x plus 7. To know the gradient, we want to put it in the form y equals mx plus c. To do that, we can divide everything through by a 3. So divide every term by 3. So y equals 4/3 x plus 7/3. So the gradient of L is 4/3. The perpendicular gradient is the negative reciprocal. So the perpendicular gradient is negative, and then this flipped over, -3/4. So our line is going to have a gradient of -3/4, and it's going to go through the point 3, -5. So it's going to be y equals -3/4 x plus c. M is -3/4, and x is going to be 3, y, when y is -5. So we can use these coordinates to find c, to find the y-intercept. So let's substitute these in. Y is -5 when x is 3. So let's multiply this. 3 times 3/4. It's the same as 3/1. So it's 9/4. So -5 equals -9/4 plus c. And to find c, we're going to plus 9/4 to both sides. I'm going to use the calculator. So -5 plus 9/4. And that's -11/4. So that's the y-intercept. -11/4. So our line has the equation y equals -3/4 x minus 11/4. Question 17. There are some small cubes and some large cubes in a bag. The cubes are red or the cubes are yellow. The ratio of the number of small cubes to the number of large cubes is 4:7. The ratio of the number of red cubes to the number of yellow cubes is 3:5. Explain why the least possible number of cubes in the bag is 88. So the number of cubes in the bag has to be a multiple of 4 plus 7, which is 11, and it has to be a multiple of 3 plus 5, which is 8. So there can be 4 small cubes and 7 large cubes, or there can be 8 small cubes and 14 large cubes. It must be a multiple of this ratio, otherwise we end up with half a cube or a small part of a cube, and the number of cubes has got to be a whole number. And the reason why this is the least possible number, 88, is that's the lowest common multiple of both of these. So 88 is the lowest common multiple 11, and 8. So it's the lowest thing that's in the 11 times table and the 8 times table. Part B says all the small cubes are yellow. Work out the least possible number of large yellow cubes. So we know the least number of cubes is 88. We know that from part A. So if there are 88 cubes in the bag, how many are small and how many are large? So there are 11 parts. So 88 over 11 is 8. So each of these parts is worth 8. So the ratio of small to large is, well, it's 4 to 7. And if there are 88 cubes, we've got 4 eighths, which is 32, and 7 eighths, which is 56. So there can be 32 small cubes and 56 large cubes. All the small cubes are yellow. So we'll just make a note of these. They're all yellow. How about the red and yellow cubes? So there are 8 parts. So 88 divided by 8. Each part's worth 11. So this is red to yellow. The ratio is 3 to 5. Each part is worth 11. So 3 11s and 5 11s. 33 to 55. So in total, we've got 55 yellow cubes. So let's just make a note of this. 55 yellow in total. And we know 32 are small yellow. 32 are small yellow cubes. So what's the least number of large yellow cubes? That's going to be 55. Take away 32, which is 23. So there could be 23 large yellow cubes, 32 small yellow cubes, and the other 33 must all be large red cubes. Question 18. The points A, B, C, and D lie on a circle. CDE is a straight line. So A, B, C, and D, that's a cyclic quadrilateral. CDE is a straight line. BA equals BD. So we've got an isosceles triangle here. CB equals CD. So another isosceles triangle here. And ABD is 40 degrees. Work out the size of angle ADE. Where's ADE? ADE. That's the one we're working out there. Okay, let's get going. So we've got an isosceles triangle here. All the angles in a triangle have to add up to 180. So if we do 180 minus 40, that's 140. And these two angles must be equal. So 140 over 2 is 70 degrees. So we've got two 70-degree angles here. So let's say BAD is 70 degrees. BAD and ADB, because angles at the base of an isosceles triangle are equal. And we've got a cyclic quadrilateral. So the opposite angles in a cyclic quadrilateral add up to 180. So 180 minus 70 is 110 degrees. So that's angle BCD. BCD is 110 degrees because opposite angles in a cyclic quadrilateral add to 180 degrees. So this is 110. Degrees. So now we've got another isosceles triangle. So we can work out the size of these two angles here. So 180 minus 110 is 70. That's the opposite of what we just did. Half of 70 is 35 degrees. So that's the size of this one. BDC is 35 degrees. And so is this one up here. But I'll just write BDC is 35 degrees. Again, angles at the base of an isosceles triangle are equal. And now we've got a straight line. We know two of the angles on it. We've got a missing angle. The angles on a straight line add up to 180 degrees. So we've got 180 minus 70 and minus 35. So taking away 105 leaves us with 75 degrees. And that's because angles on a straight line add to 180 degrees. So there's our answer, 75 degrees. Question 19. We've got a triangular prism. The base ABCD is a square of side length 15 centimeters. Angle ABE and CBE are right angles. That's shown on the diagram. Angle EAB is 35 degrees, again shown on the diagram. M is the midpoint, no, M is the point on DA, such that D to M to A is 2 to 3. So the length is 15, so let's work that out now. So it's 15, we've got 5 parts here, so each part is 3 centimeters. So D to M is 2 3s, and M to A is 3 3s. So we've got a point here, we've got 9 centimeters and 6 centimeters. Calculate the size of the angle between EM and the base of the prism. So here's M. So M to E and the base of the prism. So we're looking at this angle. So we're going to have a right angle triangle here. And we are finding this angle. This is our X. This is what we want to find out. So give your answer to one decimal place. So we can work out the length m to b, and we can work out m to b using Pythagoras, because we've got 9 centimeters, 15 centimeters. So we've got A, B, and M. So right angle, we've got 9 there, 15 there, and we want to work out M to B. So we'll work that one out. Let's do that one first. So 9 squared plus 15 squared equals our MB squared. We can use the calculator. 9 squared plus 15 squared is 306. So BM must be the square root of 306, which is, I'm going to leave 3 root 34, and I'm also going to store that as A. So I'll put 3 root 34. Actually, I'll just use the decimal because I've stored it. So 17.49. So that's B to M. This is 17.49. Then I can work out, I can use this 35 degrees and this 15. So using the triangle ABE. So we've got 35 degrees here, 15 here, and we want to know this one, which is B to E. So it's E, B, A. So it's a SOHCAHTOA. We've got, this is the hypotenuse, the longest side. The right angle's here. Opposite the angle is called the opposite, and in between the angle and the right angle is the adjacent. O is in the question, A is in the question, H isn't. So it's not SO, it's not KA, it's TOA, it's tan. So we have tan with the angle, tan 35 equals opposite, which is what we're working out, over adjacent, which is 15. We want BE by itself, so we're going to multiply both sides by 15. So we've got 15 tan 35 is equal to BE. So 15 tan 35. We've got 10.50. I'm going to store that one as B, 10.50. So BE is 10.50 centimeters again, 10.50. And now we've got another right angle triangle, and we're going to find X this time. So one more right angle triangle. So we've got our X. We've got 17.49, 10.50. So again, we've got a SOHCAHTOA question. We're finding an angle in a right angle triangle. The hypotenuse is the longest side, opposite the right angle. Our 10.5 is the opposite the angle. And 17.49 is the adjacent, in between the angle and the right angle. So again, same as last time, we're not using H, it's O and A, so it's tan. So it's tan again, and this time it's tan X equals O, which is our 10.5. over A, which is our 17.49. So we want to get the angle by itself. So we're going to shift tan. The opposite of tan, to get rid of tan, we do shift tan. So it's going to shift tan, arc tan, 10.50 over 17.49. And I did store the whole numbers in the calculator, so I could use them later. So it was alpha B over alpha A, and that's 30.98. So I'll write that down, 30.98. And it said 1 decimal place, so that's 31.0. And just to check that I've used the right stored numbers, I'll have a go with the numbers I've written down. And again, that will give us 31.0. Question 20. CDEF is a quadrilateral. C to D is A. C to D is called A. D to E, the whole of D to E, is called B. And F to C, from F to C, is A minus B. Part A, express FE in terms of A and or B. So from F to E, we can go up and round. So it's A minus B plus A plus B. So A minus B, and then an A, and then a B. So simplifying this, for A's we've got A plus A, which is 2A. And for B's we've got negative B plus B, which is nothing. So that is 2A. So F to E is called 2A. Part B. So M is the midpoint of DE. So M is halfway. So D to M is half a B. I'm just going to write this in a different color. And M to E is half a B. X is the point on FM. So X is shown on the diagram on this line, such that F to X, Fx to X to M is N to 1. So that doesn't really tell us anything. It's just saying that it's a fraction of the way across. I'm not going to write anything for that. CXE is a straight line. So C to X to E is a straight line. Work out the value of N. So this question's saying how far along F to M is this X point. So what is the ratio of F to X to X to M? So how far along this line is X? So what we're going to do, we've got these two lines we can use. So we're going to say that, well, we're going to take two different routes of getting from F to X. So we can either go part of the way along this line, the F to M line, or we can go up to C and then part of the way along the C to E line. So when we've got two routes to get there, those two routes must be equal, and we'll use that to find out how far it is along the line. So let's get started. We'll say F to X. Well, let's do F to M. Let's go the whole way of F to M first. So how do I get from F to M? I go A minus B. Then along an A. and then half a b. So this simplifies. A and A are 2a, and minus b and half a b is minus half a b. So that's f to m. F to x is just part of the way along that line. So f to x is a fraction of this. We don't know how much, that's what we're working out. So we can use a letter, we can use x. I'll use x. So x of the way along 2a minus half a b. It's a fraction of this. So that's one way of getting from f to x. I can also go up and down. So I'm going to work out c to e first. So I'm going to say c to e is a plus b. And then f to x, so to get from f to x, I'm going to go up to c, so a minus b. F to x is a minus b. And then it's part of the way from c to e, a fraction of c to e. So I'm going to use another letter. I'll use a y. So y times a fraction of c to e, which is a plus b. So I've got f to x here. This is f to x. And this is f to x from our other root. So these two things must be equal. They're both f to x. They're both ways of getting from f to x. So this one, x times 2a plus, that was a minus, x times 2a minus half a b must be equal to a minus b plus y times a plus b. So these are equal. I'm going to expand these brackets. So I'm going to say, remember, x and y, they're just fractions. They're just fractions we don't know. So they are numbers. So x times 2a, so 2 is a number, so it's 2x a's minus half x b's. And I've got a minus b plus ya plus yb. So what I can do now, I can say the a's must be equal and the b's must be equal. So I can split this out into two different equations, and they will be our simultaneous equations we can solve. So we've got a terms and we've got b terms. So the a terms must be equal and the b terms must be equal. So I've got 2xa equals 1a plus ya. And for the b's, I've got minus a half x equals minus 1 plus y. And, well, I want to eliminate y. I want to find x. So I can plus 1 to both sides. Well, for the red equation, for this one, I'll take 1 away from both sides. 2x minus 1 equals y. For the blue equation, I'll add 1 to both sides. So add 1 to both sides. So 1 minus half x. I'm also moving the 1 to the front. Instead of writing half x minus a half x plus 1, I'm writing 1 minus half x. They mean the same thing. And now I've got two things equal to y. I've got 2x minus 1 and 1 minus half x. I can make them equal to each other. So I've got 2x minus 1 equals 1 minus half x. I want to get the x's on the same side. So I'll get rid of the smallest one, or the negative one. So I'm going to plus half x to both sides. I've got 2.5 x's now, or 5 over 2. And because I'm running out of space, I'm also going to add 1 to both sides, which will give me 2. So I've got 5 over 2x equals 2. I want to get x by itself, so I'm going to multiply both sides by 2. So I'm going to have 5x even equals 4. I then divide both sides by 5. So x is 4/5. So x is 4/5 of the journey. But remember, we were dealing with a ratio thing up here. So x is 4/5 of the journey. X to m must be 1/5 because it has to add up to a whole. And we've got 4/5 of the journey and 1/5 of the journey. So what's the ratio? Well, it's 4/5 to 1/5, or 4 to 1. So f to x is 4 parts, x to m is 1 part. So our answer, n is 4.